Hey guys, welcome back. So in the last video, we learned how we can build our model for text classification. In this video, we will talk how we can train it. So we will use optimizer and we will use loss function that is already inbuilt with torch library. So we don't need to re-implement them. So we will simply use them and implement our training code. Okay. So let's see. So first let us see what optimizer we can use. There are many available. I will add some link where you can learn various optimizers we have in deep learning. Also, you can see what various loss functions we have. So we will use cross entropy as a loss function and our adaptive momentum optimizer. Okay, so let us go ahead and create an instance of this. So let us say we have optimizer is equal to, so we can simply say optim and just say double space. It will simply suggest to import it optim dot idiom and simply pass the classifier parameter. Okay, and we can access them using classifier dot model parameters. Okay, and we will use the default hyperparameters for the time being. We will see what are the various hyperparameters that we can change, but for the sake of simplicity, let us use the default ones, and let us say we have loss function is equal to nn dot cross entropy. Okay, and now let us say we want to run 10 epochs. So let us say for e in range, let us say 10 epochs, and let us compute our model. So we simply pass uh, our embedding. So in actual training, we will pass a batch of input that we will see in coming videos, how we can train actual model with real data, where we will have for example uh, tweets where we want to classify it, whether it is a positive tweet or negative tweet. So in those cases, we need to build a batching module where we will pass the text and it will return us the batches. And in this case, we will simply use the one that we have as a whole text. So embeddings we have here with 5 sentences that we will pass as a batch here. Okay, so let us pass it and get the output. So let us copy it here and simply paste it here. So, and let us comment these. What next we need to do is, for training loop, it is necessary to zero the gradient for each and every update. Okay, sorry, optimizer dot zero grad. Okay, because the optimizer keeps accumulating the gradients. So we need to zero grad for each and every update. And let us use the loss function. Let us say loss is equal to loss function, and it accepts the uh, output and the target. Okay, so we have labels here which we created. We simply pass them here, and just a caution here, we don't pass probabilities distribution that we get softmax after. We actually pass the logits, which is actually raw output after the um, final layer of the network. Okay, so it actually internally, the cross entropy function applies the log softmax and then run the loss function to get the actual loss. Okay, so let us print it. Actually, let us see print loss dot item. So if it is a scalar, you can do that as well. And let us say simply, so to run the back propagation, we simply call loss dot backward. That's it. And simply we call optimizer dot step. And this is our training loop. So you see, It is fairly simple and straightforward. So you create optimizer, pass the parameters, and then simply create a loss function given the problem, and simply run this loop as many epochs you want, and it will train the model for you. Okay, we will see like how we can save the checkpoints and how we can save the best checkpoints and so on in coming videos, but for this we will not go in details. So let us run and see like how loss is changing for this particular training data. So this is our training data. So let us run and see it. Right click and run. So it will do the embeddings and then it will run this loop. So you see here it is started with loss like 0.71 and then reduced to 52 and so on. It just keep reducing. So if you will run the test again on the test set, so we will see like we can simply use the code that we already created earlier. So this, and let us use no grad context. So with torch dot no grad. So this is simply like it won't compute the gradient for this particular code block. Okay, so let us run and see the predictions. So the actual output is like this. Okay, so let us print this as well. Print labels, and this will be the predicted output. Okay, so let us name it like F. So let us say it's true labels, and let us call them F predicted labels. Okay. Okay, so let us run and see the output after training. Okay. Okay, so you see the actual labels are 00111 and the predicted labels are 00111. Okay. Let us use actually some other text other than training for testing. Okay, so we have this test set that we can encode and then decode on this particular. So we can say like test labels are tensor, and let us say we have 0 1. At the moment we will test with just 2, and then we will see also like how it behaves with this Hindi content, which is actually other than the data we trained on. Okay, so let us run coding for these test sentences as well. So we can simply say test sentences and test sentences encoding. Okay, and now instead of using the training data, let us use these. So we simply pass this, and then instead of labels we can simply say test labels. Okay, let us see how it works for the test samples. Okay, let us run and see it. So now you see it actually works. Let us see like how it can work for multilingual setting. So we trained only on English. Let us test it for like a new language which is unseen. So let us uncomment this, which is actually machine translated Hindi segments for these two, and let us add labels as well. So it will be 0 and it will be 1. Okay, let us run. So I mean this is not multilingual model. So this one, so it should not do well in that case, because this is like English language model that we are using at the moment for getting the embeddings. To make it zero shot multilingual, we simply replace this model with this one. Okay, so we simply replace the Distilbert base NLI mean tokens with Quora Distilbert multilingual. So let us first test with the current model and see like how it works. And the expected behavior should be like it won't work as expected. So you see, the first English, it is okay, but for the other two segments which are like unseen language, from unseen language, it doesn't work. So let us simply replace our language model to the multilingual, and let us see how it performs then. Okay, so let us copy and simply paste it here. Now it should work. So let us run and see if it works now. You see, it works. So you can try other languages as well. For example, you can translate the English segments into German, French, Italian, and so on. Try them out in your known languages and see that how it performs. So in the next video, we will train on real data sets. Like we will use some data from tweet classification and also spam detection, and see that how it works in those data sets, as well as how it performs actually on real data set for zero sort multilingual transfer. Okay. So thanks for watching. Bye for now. Take care. See you in the next.